Good morning, my dear friends. Welcome to Tenali Pathshala. As you know, we have started important chemistry, chapter-wise important chemistry questions with answer series. So already I have made a video on some basic concept of chemistry, structure of atom, periodicity, organic chemistry, some basic principles and techniques, and states of matter chapters. So if you have not seen that videos, the link is given in the description. You please go through those videos, then come to this one. So in the today's session, we are going to talk about chemical bonding and molecular structure. First of all, sorry for this much light, this chemical bonding, because I have some work. So that's why it is a light, guys. Sorry for that. Yes, let us begin. Write Lewis dot structures for O2 molecules. See, O2 molecule means there is a bond between oxygen and oxygen is a divalent, therefore there is a double bond. So each oxygen is having how many electrons? Total 6 electrons. 2 are involved in the bond formation, 4 are remaining. So therefore 4 electrons we have to show with the dot. 4 electrons on first oxygen, 4 electrons on second oxygen. So this is the Lewis dot structure. A triatomic AB molecule has 2 bond pair and 2 lone pair of electrons for its central atom. Predict shape of the molecule. 2 bond pair and 2 lone pair. So you are not considering lone pair for the shape. So 2 bond pair means it should be linear, but it is having 2 lone pair also. Therefore, due to repulsion between lone pair and bond pair, your shape is bent. Shape is bent, guys. Write Lewis dot structure of CO. Again, same thing. Carbon monoxide they are asking. What is the valency of carbon? 4. So 3 electrons are involved in the bond formation. Then 2 are remaining. That 2 are shown by dotted lines. In oxygen again 3 are involved in the bond formation. 2 are shown with the dotted lines. Expand VSEPR. VSEPR. Valence shell electron pair repulsion theory. What is VSEPR? Valence shell electron pair repulsion theory. So let us talk about 2 mark questions, guys. Write a note on hydrogen bonding. What is hydrogen bonding? It is a attractive force which binds hydrogen atom of one molecule with the electronegative atom like fluorine, oxygen or nitrogen of the another molecule. So force of attraction that holds hydrogen with electronegative elements like fluorine, oxygen, nitrogen of another molecule or in the same molecule is known as hydrogen bonding. So hydrogen bonding is classified into 2 types based on where the hydrogen bond is formed. If hydrogen bond is formed within a molecule, then it is called intramolecular. Outside between 2 molecules, then intermolecular. So intermolecular hydrogen bonding is found in paranitrophenol. Intramolecular hydrogen bond is found in orthonitrophenol. So many times they have asked for 1 mark also, guys. The type of hydrogen bond found in orthonitro. Ortho means nearer to the OH group, phenol, OH group. So therefore there is a intramolecular, within the molecule, within the same molecule you are having. And in para there is no possibility of intramolecular, because in para the distance is more from OH group to the para position. Therefore there is no possibility of intra, within the molecule is not possible. So in case of paranitrophenol, within 2 molecule is possible. Therefore it is intermolecular hydrogen bond is found in paranitrophenol. Intramolecular hydrogen bond is found in orthonitrophenol. What is octet rule? Write the Lewis structure of ammonia. Tendency of an atom to have 8 electron in its valence shell. So that is what octet rule. And this is a homework for you guys. You have to write the Lewis structure of ammonia. Define bond order. Write electronic configuration of lithium-2 molecule. Bond order is nothing but number of covalent bonds between two atoms in a molecule. Number of covalent bonds between two atoms in a molecule and electronic configuration of lithium-2. So one lithium is having 3 electrons, 2 lithiums are having 6 electrons. So therefore electronic configuration can be written as sigma 1s2, sigma star 1s2, sigma 2s2. What this sigma and pi are? These are called bonds. Sigma is bonding molecular orbital, sigma star is anti-bonding molecular orbital. Distinguish between sigma bond and pi bond. This is very important question, guys. So many times this question is repeated. So let us discuss. Sigma bond is stronger bond, pi bond is weaker bond. Sigma bond is formed by axial overlapping of bonding orbitals and pi bond is formed by sidewise overlapping of bonding orbitals. In sigma bond, free rotation about sigma bond is possible. In pi bond it is restricted. Rotation is restricted in case of pi bonds. These are less reactive. Sigma bonds are less reactive, more stable. Pi bonds are highly reactive, less stable. I hope you followed, guys. So this question is very important. So many times they asked for annual examination. The resultant dipole moment of ammonia is greater than NF3. Give reason. See, guys, is it interesting? Because in NF3 more electronegative fluorine atom is there. In NH3 hydrogen atom is there. Even though ammonia is greater than NF3. Why? Because you see, in case of ammonia, the direction of lone pair dipole moment and the bond pair dipole moment is same in case of ammonia. Whereas in case of NF3 it is opposite. Thus in NH3 molecule, individual dipole moment vectors add, whereas in NF3 they cancel each other because they are opposite to each other. Hence, dipole moment of ammonia is greater than NF3. What is sigma bond and pi bonds? Axial overlapping leads to sigma bond, sidewise overlapping leads to pi bond. Covalent bond formed by axial overlapping of bonding orbital is called sigma bond. Covalent bond formed by sidewise overlapping of bonding orbital is called pi bonds. Write the Lewis symbol for elements carbon and nitrogen. This is the homework for you guys. You have to try this. You have to write the Lewis dot structures for carbon and nitrogen. Write 2 favorable factors for the formation of ionic bond. What are the favorable factors? 2 atoms must be different, then only ionic bond is possible. Ionization potential of 1 atom must be small. Electron affinity of one of the atom must be high. Electronegativity of one of the atom must be high. So these are the 4 important features, favorable factors for the formation of ionic bond. What is hydrogen bonding? Mention the type of hydrogen bonding in the orthonitrophenol. Just now we already discussed about this one. The attractive force which binds hydrogen atom of one molecule with the electronegative atom fluorine, oxygen and nitrogen of another molecule or in the same molecule is called hydrogen bonding. Types are intramolecular hydrogen bonding and intermolecular hydrogen bonding. Orthonitrophenol distance is very less, therefore within a molecule, meaning is intramolecular hydrogen bonding is present in orthonitrophenol. And in paranitrophenol and water, intermolecular and intramolecular hydrogen bond is found in orthonitrophenol. Mention the factors affecting ionic bonding. Ionization energy, electronegativity and lattice energy of the molecule. These are the 3 factors which affect ionic bonding. Mention any 2 limitations of octet rule. Octet rule does not explain relative stability of the compound or molecules, and octet rule does not explain the shape of the molecules. So these are the 2 low points, drawbacks from the octet rule we can obtain. So now let us start with 3 mark questions which are also very important. Write 3 main postulates of VSEPR theory. The geometry of the molecule depends on number of valence electron pair around the central atom. That means what is the shape of the molecule, geometry of the molecule depends on, according to VSEPR theory, number of valence electron pairs around the central atom. Electron pairs tend to repel one another because electron clouds have similar charge. The propulsive interaction of electron pair decreases in the order lone pair is greater than, lone pair is greater than, bond pair. Write electronic configuration of oxygen molecule and calculate its bond order. Oxygen molecules means O2. One oxygen having atomic number 16. Therefore, O2 molecule has 16 electrons. Electronic configuration of O2 molecule is equal to sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star px1, pi star 2py1. So this is the correct electronic configuration of O2 molecule. Count the number of electrons: 1s2, 1s2 4, 2s2 6, 2s2 8, 2pz 10, 12, 14, 15, 16. And bond order, we have a formula: number of electrons in the bonding molecular orbital, that is Nb, minus number of electrons in the anti-bonding molecular orbital, denoted by Na. Anti-bonding Na, bonding Nb. Anti-bonding means those who are present with the star. You count here without star how many electrons are there: sigma 1s2, sigma 2s2, sigma 2pz2. Correct or not? So total 10 electrons. Antibonding orbital, star, you see how many electrons? 1, 2, 3, 4, 5, 6. So 6 electrons. So 10 minus 6 divided by 2 means 4 by 4, and which is equal to 2, guys. It is a paramagnetic because there is no, it is a paramagnetic because in the last orbital you carefully observe there, one electron you are observing. That means there is an unpaired electron present, hence it is paramagnetic. Lattice enthalpy, covalent radius, bond enthalpy. We have to define all these things. Lattice enthalpy, amount of energy required to separate 1 mole of solid ionic compound into its constituent gaseous ions. Covalent radius, when two atoms are bound together by single bond in a covalent molecule, distance between two atoms from the center is known as covalent radius. Defined as the amount of energy required to break 1 mole of bonds of particular type between two atoms in a gaseous state is known as bond enthalpy. Mention the shape of BCl3, BCl2, CH4, PCl5, SF6 molecules. BCl3, 3 bond pairs are there: trigonal, planar. Trigonal, planar. BeCl2, barium chloride, linear because only 2 bond pairs are there, it is linear shape. CH4 tetrahedral, PCl5 trigonal bipyramidal, SF6 octahedral. All these structures are given in the NCERT, you see guys once. Predict the shape of the molecule having 2 lone pairs and 4 bond pairs for its central atom. That is nothing but square planar. Second one, 1 lone pair and 3 bond pairs. So it is trigonal pyramidal, just like a water. 2 lone pair and 2 bond pair, that is bent, because we are going to only consider bond pairs, not lone pairs. Account for shape of water molecule based on VSEPR theory. Oxygen atomic number is 8. Electronic configuration is written like this. Oxygen atom has 2 lone pair and 2 bond pair of electrons. Oxygen atom has 2 lone pair and 2 bond pair of electrons. Due to greater repulsion of lone pair compared to lone pair bond pair, the tetrahedral bond angle is distorted to 104.5 degree. Actually, tetrahedral bond angle is 109 degree, but Due to presence of lone pair repulsion, there is a slight less than that, and the bond angle is 104.5 degree. Water has bent or V shape. See, this is the structure of water, 108.5, or you can write 104.5. Both are correct, almost nearly equal, which is less than actual bond length. I hope you followed, guys. Talking about question number 7. Account for shape of ammonia molecule based on the VSEPR theory. Again, we have to write like that. Atomic number, electronic configuration. Nitrogen has one lone pair, 3 bond pairs. Already we have discussed about this. Due to greater repulsion of lone pair, bond pair compared to bond pair, tetrahedral bond angle is again distorted. Instead of 109 degree, it becomes 107 degree. See the picture, guys. Mention the postulates of valence bond theory. A bond is formed when atomic valency orbital. A bond is formed when atomic valence orbitals overlap with each other. Orbitals contain a pair of electrons. Electron density concentrate between bonded atoms. The strength of the bond depends on the degree of the overlapping. Important salient features of hybridization they are asking. Hybrid orbitals have equivalent in energy and they are identical in shape. Both half-filled and completely filled orbital take part in the hybridization. The number of hybrid orbital is equal to the number of orbitals taking part in the hybridization. I hope you followed, guys. This is regarding hybridization salient features. Hybrid orbitals form more stable bonds. Explain formation of methane molecule on the basis of hybridization. This is also very important question, guys. So many times this is asked as an annual examination. First, well, we have to write electronic configuration of carbon in both ground state as well as excited state. So carbon has atomic number 6. Valence electrons are also 6. So you have to write 1s2, 2s2, 2px1, 2py1 at ground state. When you give some heat to this, it went to excited state. So 2s2 is there, no? From where one electron is jumped towards 2pz. Carefully see. 1s2, 2px1, 2py1, 2pz1. Excited state, guys. In an excited state, carbon undergo sp3 hybridization to give 4 sp3 hybrid orbitals which are directed towards 4 corners of the tetrahedron. They overlap with 1s atomic orbital of hydrogen atom to form 4 CH sigma bonds. This is the structure of methane, guys. This dotted line indicates dash, and that dashed line indicates the aspirant is far apart from the teacher, or you can say the hydrogen is far apart from the carbon inside this plane you are having. And talking about the dark sided, that is called wedge, and that wedge is indicated the hydrogen atom is front of the plane towards the observer. I hope you followed, guys. Geometry is tetrahedral, very important. Hybridization is sp3, guys. You remember at least this trick. All are singly bonded towards the carbon atom. It is sp3. Any one double bond, sp2. Any one triple bond, it may be sp2 or it may be sp. Bond angle 109.5. Explain sp2 hybridization by taking BCl3 as an example. Again, you have to write ground state, excited state. In an excited state, boron undergoes sp2 hybridization to give 3 sp2 hybrid orbitals which are oriented in the trigonal planar geometry, just like a triangle arrangement, and overlaps with half-filled orbitals of chlorine atom along the axis to form 3 BCl sigma bonds. This is the structure of BCl3, guys. I hope you are following this one. Question number 12. With respect to formation of ethene molecule, mention hybridization of the carbon. Ethene, sp2. Number of sigma bonds in the molecule. You see the structure yourself. How many sigma bonds are there? 4H are there, 4 sigma bond. CC double bond is there. No, out of that one is pi bond, below is sigma bond. So total sigma bonds are outside 4 and inside 1. That is what? 5 sigma bonds. Number of pi bonds only 1. Question number 13. With respect to formation of ethyne molecule, mention hybridization of carbon. Number of sigma bonds in the molecule, number of pi bonds in the molecule. Hybridization of carbon atom. I told you any one carbon atom is having one of the double bond, it is always sp. And number of bonds are, how many number of bonds are there? Sigma bonds. 2H CH bonds, sigma bonds are there, and one is from the last line of the triple bond. So I hope you know, guys. Double bond is there, upper is single bond, lower is single bond. Upper is double bond, lower is single bond. That is upper is pi bond, lower is sigma bond. If triple bond is there, upper and below both are sigma bond, and middle one is upper and below both are pi bonds, and middle one is sigma bond, guys. For H2 molecule, write the electronic configuration, calculate its bond order, state its magnetic property. Again, H2 molecule contain number of electrons as 4, sigma 1 s2, sigma 2 s2, like that you have to write. But electronic configuration of H2, not helium 2. So one hydrogen containing 1 electron, 2 hydrogens are containing 2 electrons. So bond order is again same. Number of electrons in antibonding, bonding minus antibonding, Nb minus Na divided by 2. So how many number of electrons are present in the bonding? All the electrons are present in bonding only. So antibonding 0. 2 minus 0 divided by 2. 2 to get cancel, you will get 1. And there is no unpaired electron in the outermost cell. Hence, it is diamagnetic. For Li2 molecule, write the electronic configuration, calculate its bond order, state its magnetic property. Electronic configuration of Li2 molecule, again same, hydrogen, helium, lithium. 3 2s are 6 electrons should be filled. Sigma 1s2, sigma star 1s2, sigma 2s2. Last valence electron came in sigma 2s2. Last electrons are present in sigma 2s2 orbital, and there is no unpaired electron, hence it is diamagnetic. Again bond order is Nb minus Na divided by 2. Nb is number of electrons in bonding orbital, Na is number of electrons in antibonding orbital. So antibonding means star. Star only 2 electrons are there, guys. Remaining 4 are in bonding. 4 minus 2 by 2. So 2 by 2 you will get 1. Give any 3 postulates of MOT. Electrons in a molecules are present in various molecular orbital as electrons of atoms are present various atomic orbital. The atomic orbital of comparable energies and proper symmetry combine to form molecular orbitals. The atomic orbital is monocentric, only one center is there, while in molecular orbital it is a polycentric. The number of molecular orbital formed is equal to number of combining atomic orbital. The bonding molecular orbital has lower energy and hence greater stability than the corresponding antibonding molecular orbital. Molecular orbitals like atomic orbitals are filled in the accordance with the above principle, obeying the Pauli's exclusive principle and Hund's rule. So all these I have taken from the NCERT only, guys. Whatever NCERT they have given, same statements I have written here. Sometimes they will ask, write any 2 postulates of MOT. So that time you have to remember. Explain formation of PCl5 molecule on the basis of hybridization. Again you have to write ground state, excited state. In an excited state, undergoes sp3d hybridization to give 5 sp3d hybrid orbitals which are directed towards 5 corners of the trigonal bipyramidal. See the picture, guys. They overlap with half-filled orbitals of chlorine atom to form 5 PCl sigma bond. Geometry is trigonal planar bipyramidal. Hybridization is sp3d. Explain formation of SF6 molecule on the basis of hybridization. Atomic number is 16. Again, this is a ground state configuration, excited state configuration. This is the structure. In an excited state, sulfur undergoes sp3d2 hybridization to give 6 sp3d2 hybrid orbitals which are directed towards the 6 corners of the regular octahedron. and they overlap with the half period orbitals of fluorindum to form 6 sf sigma bonds. Octahedron means the shape is given in the picture, that is what called octahedron shape. Geometry is octahedral, so hybridization is sp3d2. Describe LCO method for formation of molecular orbital of the hydrogen molecule. Write the energy level diagram for the orbital. This is energy level diagram, guys. The molecular orbital sigma and sigma star formed as sigma bonding molecular orbital, sigma star anti-bonding molecular orbital. I hope you are following the picture. Two hydrogens are there, one s and one s. Two hydrogens are coming nearer. Electrons are taken by the electrons are overlapped to form sigma bond. Hydrogen molecule has two hydrogen atoms, A and B. Their atomic orbitals may be represented by wave function xi A and xi B. Molecular orbitals formed by addition and subtraction of 1s atomic orbital. Xi of molecular orbital is equal to xi A plus xi B. Explain sp2 hybridization in ethene. This is also very important question, guys. So many times they have asked. So carbon atom in the ground state, carbon atom in the excited state, carbon atom in the hybridized state. So when you observe from ground state to excited state, what is happening? In 2s2 electrons are there, no? One of the electron is jumped towards p orbital. As a result, 1s2p combine to form 3 sp2 hybrid orbitals, and the hybridization is sp2 hybridization, guys. I hope you are following. That only I have written here. If you want to take screenshot, you can take it, guys. Yes. Explain sp hybridization in ethine. Very important, guys. Ethene and ethine, again same. Sp means triple bond. So carbon atom in excited, carbon atom in ground state, carbon atom in hybridized state. Sp hybridization, sidewise overlapping gives pi bond, lateral or axial overlapping gives sigma bond. Already shown in the picture. Carefully observe, guys. In ethine, both the carbon atoms are sp hybridized and have two unpaired electrons in the unhybridized p orbital. One of sp hybrid orbital of both the carbon atoms overlap each other to form carbon-carbon sigma bond. Other sp hybrid orbitals on each carbon atom form sigma bonds with the hydrogen atoms. Two unhybridized orbitals on each carbon atom overlap each other sideways to form one carbon-carbon pi bond. I hope you followed, guys. So if you are not getting anything, please see the video once. So if you are having any doubts, you comment below, guys. If you are not getting anything, means see the video once. So I hope this video is helpful to you, guys. If it is helpful, please like the video, subscribe the channel and click on the bell icon so that each notification when I upload the video, you will get a notification to see the videos. So this is the last lesson for midterm exam, guys. The remaining lesson I am going to do after the midterm exam for annual examination purpose. These whatever I did know, the chapters, those are helpful for midterm as well as annual exam. Stay tuned for next lesson, guys. Thanks for watching. Thank you.